So our next speakers are here, Chandrani and Shruti from Adobe, and I was really excited to be able to get I think a lot of us are been talking about from the ISV side or the maker side, but here they're actually having to protect the enterprise, and so I was really excited to be able to learn a bit about somebody as large as Adobe, how they're thinking about it.
Yeah, thanks so much, everybody. Thanks so much for the introduction. Hello, everyone. We are here from Adobe to talk about a project, how we are democratizing security guidance as a service, right, across various different platforms. So a little bit about ourselves. I'm Chandrani. I'm with Adobe Security for about 7 years now, and in the security space for about 10 years.
Hi everyone, I'm Shruti Datta Gupta. I'm a product security engineer at Adobe, and my background and work so far has been at the intersection of AI and security. I've been in the space for over 5 years now.
Before we go into like what we have developed and into the nitty-gritty of it, let's first talk about like what drove us into this problem statement, like what was the gap that we were seeing at Adobe, right? So like the first problem is the scalability, right? Like for example, developer to the security researcher ratio is always very high, and then there is we cannot really get to one-on-one guidance and things like that. So there is always a knowledge gap between the developers and what we security researchers know. The second one is again scattered communication. So there are various different platforms, like I'm sure like in Adobe also it has, and in your organization as well, like there are Jira tickets where tickets come in and people need guidance. Then there is IDE where now all this AI assisted IDE where we need to know what developers need to do and things like that. Then there are Slack channels, people come in and ask. So there are various different platforms wherein people ask maybe similar questions, and we need to give in like same information as well. And then there are plethora of information, right? There is no dearth of that. But like there are wikis, and all these guidances are created by SMEs as security champions. But I think the challenge was to get this information to the right person at the right time. That was the challenge we were facing. If I need this today, and if I'm able to find it, all that wiki search toil and everything after 2 days later, it doesn't really make much sense. Now with AI, obviously it changes the equation, right? It understands natural language. We are all in a time machine, I mean going super fast. But then there are little bit nuances as well. Like when we are relying on AI to give us security guidance, it gives a generic answer, right? It doesn't give like your organization specific, like just now they gave like the policy details, or many organizations have like specific platforms, right? For example, for authentication, for authorization, we have specific platforms built, and how to use those, how we can onboard to those. So those are very org specific context information that we need, that obviously the generic LLMs will not have. And then there is also the risk of hallucinated response, right? So keeping all this in mind, what we thought we wanted to build was like a security bot, or maybe a security as a service, which will be platform agnostic. Right, so be it Jira, be it we have an automated threat modeling platform as well. So be it that, or maybe in the IDE itself. So wherever it is coming from, we will be able to provide the same security guidance, and of course it will be backed in the back end by some vector database. Those documents will be embedded and put in over there. So whenever we are asking some information, some question about that, we are able to pick the right information from there. So that was the intent. So before I go into again like more the architecture and the data flow of it, let's talk about whatever we are going to say, whatever we are going to present. It was not that we had the entire picture built in our mind, entire architecture built in our mind, like in the day one itself, right? It was like over at least 1.5 years to 2 years worth of effort that we are telling it here. So initially, of course, that org-specific details and everything that we had in mind, we started with a RAG solution, right? Because we needed Adobe-specific context. Sorry. To start with, the first place that we integrated it was in the Jira, because that is the place where all the pen testing tickets or the bug bounty program tickets, they come in and they have the SLA. So that's the one we need to really have the guidance like right away, so that those are fixed on time. So what we did was we collected like whatever we could from our security SMEs and security champions, like 50 to 60 docs, generated the embeddings, generated the numerical representation of it, and then put it in the vector store. Right, and then it was almost at the same time, it was also realized in a Slack channel itself. So it was there in two places. But then soon we realized that there are other platforms where that could leverage this information as well. Like, for example, there was a separate team at Adobe that is working on, that has built an automated threat modeling platform, right? So for that guidance as well, we need that. Then when all these AI-assisted IDs came in, we developed an MCP server, so that similar guidance would be needed there as well. Right? So then we understood like we need some type of automation for the document ingestion part as well, because so far in this chart that you are seeing in this flow, the Jira or the Slack, we had like 50 to 60 docs, right? But when I'm talking about we need automation across even more platforms for that, the number of documents are increasing. And there was automation, but it was a semi-automated flow, right? Semi-automated, why I'm telling is, because generating the embeddings, upsorting it to the vector store, those we have endpoints and things like that. But then even before that, collecting the document, creating the PDF or extracting the text out of it, that was still a manual process. So so in the process, we also actually built an automated document ingestion pipeline, which we are going to talk about. And simultaneously, it was also, we had endpoints published for thread guidance that was connecting to the same vector store. We have an MCP server where within the IDE people can call it. So now it is like we are pushing for the usage of it. Now talking about the doc curation workflow and the ingestion, what we built. So here, the idea was whatever is there in the backend should be there in a repo, right? So there will be a metadata repo, and that will be the source of truth. So whenever, say for example, I'm an SME, I have created some secret ingestion, like some documents. So I'll have to come to this repo and then create some, some metadata, like what is the URL, what is the document about, some very basic information, right? So I do a PR, and then we do a validation, and we merge the PR. Then there is an upstream service, which is the downloader. It's based on a pub/sub model. So the downloader picks up this PR, and it gets the content of the page. Right, and then we also take care, like for example, say URL A has already been ingested using this flow, but there has been a change, right? So we have a cron job that goes through like what is the delta, and then we fetch that delta content into that S3 bucket. And then upstream there is an ingester service, which would take all this, all the downloaded docs. It will create the embeddings and everything, and then it will put it in the vector store, right? It will put it in the assistant. Once the entire process is done, we have a Slack channel to mention that, okay, this document has been uploaded to this vector store. And then we have a evals in place. Evals in the sense, when initially itself I'm taking the document, dictionary kind of a thing, where I'm giving a question and answer set, where some 2-3 preliminary questions that can act as a reference set for that particular doc, like when I wanna test it, like after the ingestion, whether, you know, if I'm getting the correct answer or not, so that I'm able to do it in that once I get the Slack notification. So now about the main architecture of the security bot. So as I was saying that the inputs can come from multiple different platforms, right? Be it a chatbot or IDE guidance, vulnerability agents. Everything goes through an AI orchestrator first. Once it and then on the once it receives, it basically it goes through a prompt engine. So we tweak the prompt in each case. And then we go to the vector store, we collect that information. It again goes through an a curated response LLM flow. And then everything we are also logging in the Langsmith for traceability and observability information. Over to you, Shruti.
Awesome. So we've seen what the architecture looks like. Let's look into some examples of what this looks like in practice. So the first example was around the security support chatbot. So we implemented this via Slack. This is essentially, let's say anybody in the company has a security question. They come to this Slack channel and they ask the question, and we are basically retrieving the guidance from our vector store. So think of questions like, how do I do X at Adobe? What is the recommendation to do Y at Adobe? So this is an example that asks for standard security guidelines for using third-party SDKs. And again, the query is entered by the user in Slack, and then the Slack app is actually talking to our service, getting the guidance out, and then putting it out here in the Slack channel. The next example is threat remediation guidance. Like Chandrani mentioned, we have a sister team that does threat modeling, and they built an AI automated threat modeling engine. So once the AI agent identifies the threats, again, this engine makes a call to our guidance as a service, gets the requisite corresponding guidance for each of the threats that are found, and then surfaces that guidance back along with the threat model. The next example is on the shift right side of things. So when we have vulnerabilities that are reported by, let's say, bug bounty findings or pen test reports, right? So we have a vulnerability triage and ticketing pipeline. So when that pipeline gets triggered, when there is a new finding, they again make a call to our service. They send us all of the details of the vulnerability, the exploit, and everything. And then we get the guidance out. Here you can see that the formatting looks a little bit different. So for vulnerabilities, we provide not only the short-term fixes, but we also provide long-term fixes. So sometimes you can have a one-off fix that can remediate a vulnerability. But when you have let's say product teams who are seeing multiple vulnerabilities belonging to a certain class, then we also want to guide the engineering teams with long-term fixes that they can look into to mitigate that entire class of vulnerability. Finally, we have the in-IDE guidance. So this is via the MCP server, and this is meant to provide the same guidance to developers as they're writing code while they're in their development workflow without having to leave their development environments. So actually, I'll show you a pre-recorded demo over here. So here I'm in Cursor, and you can see here, we are connected to the Adobe Security Guidance MCP server. Right now we have just one tool, which again makes a call to the service and gets the guidance. This is an example wherein we asked it to generate the best practice guidance for SQL injection. Just a quick note here, we found that explicitly pointing it out and saying, hey, call the MCP server gives you better results. There's also another way to take care of it through skills, but you prompt it, and then basically the cursor coding agent is then, it is connected to our MCP server, it identifies the MCP tool, and then it sends the request to the MCP server with all of the details about SQL injection. We get the response back, and then it is formatting and pretty printing all of that information as guidance to the developer, right? And here I want to also show you that we are giving the citation to the actual document that we are pulling this guidance from. So if you want to dig deeper and get more information, we are giving you the right resource to go take a look into. Another example here is to generate best practices for HTTP headers. Again, very similar workflow, the cursor coding agent then calls our MCP server. Here in this example, it had to do like a couple of iterations to get the right information out. But then again, it is pulling out all of the information. Here, we have like 5 bullet points that is coming up and then 1 cited resource. So here actually for the MCP server, we set a higher threshold for retrieval. This is again something that is configurable based on where the request is coming from. And I'll show you what the Slack workflow looks like in a minute. So this is the Slack workflow for the same request, best practices for HTTP header. We are getting the same response, just some additional response because we have a lower threshold for retrieval over here. And you can see again, the same citation as before and an additional citation. Another thing to look for in the Slack workflow is the online evals that we are doing. So once we give out the response, we prompt the user to tell us whether the response was a good response or a bad response. This enables us to get real-time feedback from users. And once you hit on, click on bad response, this basically initiates this workflow. It requests the user to give feedback on what didn't work. Typically, it can be one of 2 cases. Either we do not have the document that answers your question, or we have the document and it does not contain the updated information that answers your question. Either way, once you enter your feedback, click on submit. This triggers a workflow that notifies our team so that we can get in touch with the document owners, and whichever is the case, we can have the most updated documents in our pipeline. So this was the quick demo. To wrap it up, some of the challenges and lessons learned here. First of all, building the reference set of evals. Now we have the doc ingestion workflow, so we are enabling or requesting doc owners to add those reference set of evals, but this is also something that was manual and cumbersome, and we had to do manually initially when we were first building our vector stores. And again, like, second point is around updated docs or doc freshness. This is a continuous challenge. We have automated the workflow to take care of this, but making sure that since our vector store is somewhat like the single source of truth, making sure that we have the most updated documents there is important. In our doc ingestion workflow, we have a PR review step, right? So right now, again, that is manual, but it can be a bottleneck. Right now, we are okay with that trade-off because that ensures that we maintain high quality of the docs ingested. But that is definitely something to reconsider if we get to that in the future. And finally, AI is evolving at a breakneck speed. Like Chandrani mentioned, we started building this like 2.5 years back. So we have had to keep pace with the evolving technology so that what we are building is not only using the latest and the greatest state of the art, but it's also relevant and useful for our developers. So to sum it up, few takeaways from our session. AI is helpful in security use cases. It is very helpful, especially when we think about providing guidance and democratizing guidance. But you need to provide the relevant context. Context is king to ensure we get the most out of state-of-the-art AI. We were able to centralize this guidance over time, and that enabled us to provide consistent, scalable guidance, security guidance to developers at every stage of their development cycle, whenever and wherever they need it. And finally, evals are important, and evals are what will turn your AI experiments into production systems. With that, Want to make a quick shout out to the team who built this. Of course, this is not a 1-person or 2-person project. We have an entire team working on this. So big shout out and thank you to the entire team. And with that, thank you. Please connect with us on LinkedIn, and we are happy to open the floor for questions.
Yeah, questions around kind of the document, using the document storage for the guidance piece. So you've solely used vector stores for the document store, and how are you seeing like consistent use of those documents in like larger complex guidance flows? Have you looked at using knowledge graphs to get better consistent like flow data? I find with 1 million documents, technical documents in cyber data, when I go like, hey, can you go give me guidance, it flops over with just vectors. So yeah.
Yeah, so for the document ingestion part, currently we have done it for the wiki platforms only, right? Only it works for the wiki, and then some of the Adobe's internal platform, there are still like multiple other platforms where there are docs, which we do not have the code yet to ingest automatically. Right, and to answer your questions like graphing the doc, or if people are using it, so at least for the Jira guidance that we initially started with, right, which is there at least now 1.5 years almost, we have got the feedback with the guidance over there. People are able to close out the tickets sooner. The MCP server and the thread guidance is very fresh, in the sense like 6 months old. So I think we still do not have that much feedback yet. MCP server is actually even much newer, but people are using it, at least that's what we hear. But again, we are not talking to each and every entire Adobe developers. We try to do roadshows and everything, but then it is like on us doing the development and the roadshows and everything. Yeah.
To follow up on what she said, security guidance is not necessarily a lot of best practices. There are some fundamental best practices that you need to follow. And time and again, we see that even though they're fundamental and everybody should follow, they do not follow. And what happens is, as products and systems evolve, these documentations keep growing. So you might have like 10 different versions that's saying the same thing, but you don't know which is the correct version. So I think we are solving more of that problem, so that as a developer, when you want to find out, oh, how do I fix a SQL injection vulnerability, I don't have to go and search what the right document is. That document is provided to me by the security team. So far, we've not necessarily seen a need for having a knowledge graph as opposed to a vector store. Yeah.
Any more questions? I guess I have one. It's always interesting how things fail, right? And so I was also, first of all, thank you. This is so cool. I was curious about two points of failure and how to deal with the handoffs. One is at the ingestion point, like you mentioned that things, like you catch that things may be ingested wrong because the eval failed or whatever. So I was kind of curious, like, is it like, and actually even before then, there's a question of, first of all, who writes the eval? Is that your team or the person who wrote the doc? Like, how does that get figured out? And then if the eval fails, whose responsibility is it?
Yeah, there are few other failure scenarios also. Like one happened actually last week only, because we did it for wiki, and then I think last week there was some updates in the wiki format or the platform itself. So we have the logic works on a certain kinds of macros or something like that was updated, and so the document ingestion part started to fail. Anyways, we were able to figure that out. We were able to put in that logic. And I'm sorry, what was the other question?
So the question is, do you expect do regular engineers do the evals, and then when a document fails to ingest, whose responsibility is it to fix it?
Yeah. So it is like a shared responsibility model. That's how we are, giving it out. We can put in the evals questions, but then it becomes a lot of onus on us. We don't really want to do it. So whenever people are giving us the doc for the PR, we are asking them to give those at least 2 evals question. It's not a lot. and they can generate it via the AI with the content and all that, right? So yeah, if it is not there, I mean, with even after asking, maybe at that time we add it, but we want to make sure that the evals questions are there.
We started doing it from our team when we were small, and we had fewer documents, but naturally as we scaled and we started adding more documents, it was not scalable for our team to take responsibility for all of it, which is why we are doing like a shared responsibility model wherein the document owner is responsible for adding the evals as well. Yeah.
Any more questions? So I think we're, so first of all, thank you